Okay, so this topic is solving one variable equations toolbox. So you got 4 steps. The first thing, if you have a one variable equation, so you've only got an x and a bunch of other numbers, might be lots of different kinds of x's, but there aren't going to be any other variables. You distribute first of all, and so often you have to put things inside parentheses so that you can actually get it to the place where you have one variable on one side. The step 3 is actually sort of your goal to begin with. You want to get to the point where your variable is on one side. So first you usually distribute, and then you simplify each side, and then you move things so the variables are on one side and everything else is on the other side, and then you solve using inverses. So solving proportions is another little nutshell kind of special thing to do. So when you have proportions, you have 2 steps. You cross multiply, and I drew one cross multiply there in green and the other one in purple, and then you solve for x using your standard methods. So one thing you have to be very careful of if you're going to solve proportions is you've got to get each side of the equation so it's a single fraction. Like if I had a x plus 3 over 2, I cannot cross multiply. You can only cross multiply because it's a single fraction here equals a single fraction over here. However, it's getting it to this form, then we're going to follow these steps. So the first step is to actually do that cross multiply. Very important again to use parentheses. So 2 is going to end up being times the entire numerator of the fraction on the right. So it's 2 times 2x minus 1. And then the other side becomes 6 times x plus 3. Then we can use our standard methods. Distribute, simplify, move so variables are on one side, constants on the other, and then use inverses to solve. So distributing, I have 4x minus 2 equals 6x plus 18. I'm going to subtract 18 from both sides in order to move the 18 away from the right side, and I'm going to subtract 4x in order to move the 4x over to the right. So I'm basically collecting all my x's on the right and all my constants on the left. So that gives me minus 20 equals 2x, and then x equals 10. Okay, verbal to algebraic expressions. One of the things we're going to learn actually is that there are 4 different ways to represent any kind of algebraic expression: as a graph, as a table of numbers, as an algebraic expression, and then as words. And so a lot of times what's hardest for students is going from the words back, the verbal back to algebraic expressions. But for the most part, they pretty much map, and there are key words that tell you exactly what to do. So you look at and then translate the specific words. So we want to take 3 less than 1/4 of a number. So of always means times. So I'll usually start with the of and do my time symbol. A number, I always like to represent by x. 1/4 of a number means 1/4 times x. And then 3 less than 1/4 of a number. So 3 less than 1/4 times x becomes 1/4 times x minus 3. All right, so in next example, 4 times, so 4 multiplied by, the sum of a number and 47. So the sum of means plus a number, x, and 47. So the important thing here is to recognize that the sum of a number and 47, you're taking 4 times that. So the 4 goes outside the parentheses. All right, then let's look at the next one. The difference of 12 and half a number. So the difference of is going to mean minus. So we're going to have 12, and half a number is really short of saying half of a number. So it's going to be 1/2 times x. So I think we're going to get 12 minus 1/2 x. All right, and then we have, last example, the product of, so that's multiplying together a number, so this is going to be, it tells me it's x times the product of a number and 9 decreased by the square of the number. Okay, so starting on this side I have 9 decreased by, so 9 minus the square of the number would be x squared. So this part over here is going to be 9 minus x squared, and then I'm going to multiply by x. So 9x minus x squared. Welcome. This topic is verbal to algebraic expressions. It's kind of an interesting thing that algebra can be represented. There's an acronym called GNAW, G-N-A-W, and an algebraic expression can be represented graphically with a table of numbers, with the algebraic expression, and with words or verbal. And so the hardest part for students is often going from a word problem back to the algebra statement. And so what I have lined up here is an example, but there's some very clear translations that we can use, and one of them is shown here, and then we're going to practice 3 others. So we have 3 less than 1/4 of a number. So the 2 things I do right away are usually highlight a number, call that x, and then there are certain words verbally that go directly to math symbols. Of by itself means multiply. And so I know right away that I'm going to be taking 1/4, 1/4 of or times a number x. All right, so then going back to the big statement, I want 3 less than 1/4 times x. I'm going to turn around and put minus 3 over here because that'll take me 3 less than. So of is one of the big easy translations. As soon as I see of, I'll put times. As soon as I see a number, I'll put x. Another good one that's actually not represented here is the word is. When you see is, that's where you put an equal sign. All right, so let's look at 4 times the sum of, so this is not of by itself, this is the sum of a number and 47. So the sum of is plus. So we have a number, x, plus 47 times 4. All right, the next example, the difference of, again, of is not by itself, so the difference of is going to be minus 12 and half a number. So there's an implicit of here. Like it doesn't say it, but this really means half of a number. So like we did up here, that's going to be 1/2 times x. So the difference of 12 and 1/2 times x is going to be 12 minus 1/2 x. All right, and the last one here is the product of a number and 9 decreased by the square of the number. Okay, so the product of a number and 9, that tells me I'm going to take x and multiply by 9. So 9x decreased by the square of the number. So that'd be minus x squared.